Okay, so good morning. Today's lesson we're going to start creating a project in C# that uses a relational database. So could you open up Visual Studio for me, please? Let's make a new project. I would like Windows Desktop, and it should be a Windows Forms app. You have to save it in the right folder, and let's call it My Finances. We'll make a little app that allows people to store sensitive information like how much money they've got. So we're going to create some tables in a database. We're going to make it so that students or people can log into their database and see transactions. So a graphical user interface form project. I've called it My Finances and I put it on the W drive. First thing that we want to be able to do is make a login screen. So let's change the properties here. We can change the properties of this to have login screen, maybe with a space in on the text. Oh dear, I've got rid of my toolbox thing. I can never remember how to get it back. Is it under view? Yeah, view and toolbox. There it is. I need a login button. And I'm going to need some labels. Spell properly. Control C, Control V. I want a label for username, a label for password, and then a text box next to both. Control C, Control V, so that they're lined up. The idea is I only want to be able to access my financial management spreadsheet thing if I've logged in with the correct username and password. Let's change some properties on here. Let's say this is just going to say username. The text property of this control is going to be password. I don't really care that this is called label 2 because it's not going to be dynamic. I'm never going to change any properties of this in code. I do care that the name of this is going to be something that I can access again later. So I don't want text box 1. I'd like it to be called txt username so that I can access its value from code. Txt password. So if we run it at the moment, it's not console based. It should display as a window, a graphical user interface. Here it is. It's on my other window. There we go. You can type something in and you can type something in. I don't want to be able to see that because it's a password. So we can change the password char property here to an asterisk, which hopefully means that I can see my username, but I can't see the password. That was the password char property. And then we need to rename this button and change the text property. So I'm going to call it btn, login. And then we should change the text property to login. So that hopefully, I mean, I know it won't do anything yet, but you can put string and really super secure password, and we have our user interface. Good. So we've made our user interface. Now we want to put the database in place. So if you right click on your solution and add, we want to add an existing item. In fact, sorry, it makes much more sense to right click on the project rather than the solution. So right click on the project and add, you get more options then. Let's go for a new item. And we want a data item, and it should be a service-based database. And it will generate an MDF file, that's fine. And let's call it Finances. That will add a database to your project. So that was right-clicking on the project, add, new item, and then we want a service-based database, which is in the data section. Might look a bit different if you're doing this from home, because the things will be in a slightly different layout on Visual Studio 2019 or 2021. But you should be able to search for it and find it. I've called mine Finances, and this is a database that is then going to be bundled with your project. If you double-click on that database, you will see it in the Server Explorer, the data source thing over here. And it tells us we've got some tables to play with. So let's make a new table, shall we? I've right-clicked on tables and add new table. And we're going to define the table. You can define it with transactional SQL, or we can define it with our fields, like a graphical user interface. We're going to do this one. So let's think. We need to store our usernames and our passwords. We want it to be normalized to 3NF. So we'll have an ID, good, which is the primary key. Let's also have a username, which is going to be varchar 50, up to 50 characters for our username is probably fine. We don't want to store a hash. We want to store a password. Sorry, we do want to store a hash of the password. Let's call it password hash. Oh gosh, then we need to work out how long the hash is going to be. Should we use SHA-256? How many characters? 64 characters. There we go. If we want to store an SHA-256 hash, then we're going to need 64 characters. Let's just change that to be 64. So we had a really good question about allow nulls. No, we don't want nulls for username or password. But if we put in a first name, let's not have any spaces, and a last name, I think those can have null. We don't, strictly speaking, need those. But we want more than 10 characters. Let's say up to 128 characters. Oops, not a big int. And char 128 and char 128. So you don't need to remember all the different data types here. There are all sorts of different ones you can play around with. You'll not be tested on any of that. You just need to find something suitable. What we do need to know is this is a primary key. It's going to be unique for every value in the table. Down in the SQL, you'll see whatever you put in here is instantly updated. Well, almost instantly. So let's rename our table. I'm going to get rid of the dbo.table and just put users. And then as soon as you change users there, you can see it goes to users at the top. And then I'll press the update button and it will say, oh, I'd like to make this. Let's upgrade the database. Or it can generate a script for you to write the SQL to create all of that kind of gubbins. No thanks, don't really care about that today. But the point is that we should now have a users table. With our users table, we should be able to right-click and show table data and add somebody in. So let's have one username. You can put your own data in. I'll put Mr. Dring, password hash. Oh gosh, is there an online SHA-256? I'm going to go for a horribly insecure password like password. And there's my SHA-256. Plop that in there. First name, last name. And that is now in the database. Now exists in my database. If you haven't done this right, it's probably because you've set the wrong data type to this, and you can always edit that. You can right click and open the table definition, and you can change it to make sure that you have actually got 64 characters. If you haven't got 64 characters, you're going to truncate, chop off part of the hash, which is going to make it really insecure, because it's only going to check the first however many number of bytes to see if that part of the password matches. So before we start writing our code in our project, we'd best talk about how we can interrogate databases generally. So we're using the W3 Schools webpage for this because there's a database all set up and running. Just going to click on Try It Yourself, and let's have a look at, well, customers is probably the closest to what we've got. It doesn't have password hashes, but it does have people. The idea is we don't care at this point whether you're storing your data in a MDF database or an Excel spreadsheet or a file or an external server, or MariaDB or MySQL or Postgres or like Oracle. We don't care how it's actually stored. The way you interact with it in your code uses abstraction. We hide the unnecessary details of the actual implementation, and we just want to write a query, write something to be able to interrogate this database. So structured query language is a pretty much universal way of interrogating relational databases. So the idea is you can say what you want to find from whichever table. So if we're saying select everything from the customers table, then we've got everything here. But if you only want maybe the customer name, it's only going to show that field. And you can specify more than one thing. So if we want the customer name and the customer ID, that's customer ID, comma, then we can just specify what we want. So you will have to know in your exam how to understand and write SQL statements. This is searching. We can also narrow things down, and we can say select which fields we want. I tend to put these on separate lines. Those are the fields we want. This is the table we're interested in, and we can put a where clause in, and we can say where, I don't know, where the customer ID is equal to, and then a number, so we can narrow it down. Or you can say where customer name is equal to, and I'm not going to be in this database, this isn't going to find anything. But you can also say find everyone whose name begins with A, and then an asterisk, a wildcard, to try and find everyone whose names begin with that letter. Or, and as well if you like, you can order them by customer name, if you can spell by properly, ascending or descending. Oops, what have I done wrong? Oh, I haven't put anything in here. Custard name, there we go, customer. So that's sorted ascending from A to Z, or we could do descending from Z to A. So you've got your select clause. These are the fields you want to show. That's the table you want to search from. And then you've got your where clause. So I don't know, where customer ID is greater than or is less than 10. Don't know why you'd want to do that, but why not? Sorted by, and then your sort clause on here. Okay, so let's head back to our code then, shall we? Go back to form1.cs, double click on your login button, and this is the code that's going to happen when you attempt to log in. So we want to be able to extract the username and password. So let's do that first. Username is equal to, at this point, hopefully you renamed your button controls, sorry, your text controls, txt username and txt password. So txt username dot text and string password equals txt password dot text. Then we want to be able to generate some SQL. Well, first we're going to have to hash our password to try and work out what it is. So this is why we should have been doing our compete.withcode.uk stuff to see if we can remember how to do it. We need an SHA-256 object, which we don't have access to, Alt-Enter, unless we do using system.security.cryptography. There it goes. I'm going to call it hasher. And then we'll make one, SHA-256.create. How do we display something to the output, like a console? I can't remember. System.diagnostics.log, event log. I don't know. I have to pause and try. There we go. Sorry. Furious Googling later. I want to be able to write something to the output console, and I'm going to use debug. So Alt-Enter using system.diagnostics, just so that we can see something. attempting to generate a password hash for, I want to show the password here, which means I need to interpolate that string. Will it work? If I put in a password of blah de blah de blah, and then click on output, where's it going to appear? Yeah, that's better. So it doesn't work if you press Control F5 to execute it properly. You have to do just F5 to debug it, and then when you press login, you can see the login, like the debug messages down at the bottom. That's better. Okay, make it full screen, Alt-Shift-Enter so that you can see the code a little bit better. All right, we've made a hashing object. We want to be able to get the bytes for the password. Done this a couple of times now in the complete.wecode.uk stuff. So password, we need to get some bytes for it. So an array of bytes, coding.ascii.getBytes. So that will generate the hash, but it's going to be in actual binary data, and we want to represent that binary data in hexadecimal because that's what's stored in our database. So how do we do that? Well, we're going to iterate through each of those bytes. For each byte B in our array of bytes, let's make something to store the hash. Starts as an empty string, and then we'll concatenate onto the end of it something. What are we going to concatenate on? Well, we want to concatenate the current byte from our SHA-256 hash, but we want to represent it in hexadecimal, and we need to make sure it's represented as 2 characters, because 2 characters of hex is 1 byte. As in, if it's just a 0, we need to represent it as 0, 0. Otherwise, it's not going to be correct. So let's see if this works. Debug.writeLine hash, or SHA-256 hash would be better. Will it work? Let's press F5 and hope for the best. Empty string, attempting to generate a password hash for blank. SHA-256 hash is blank. Well, that's rather worrying. It shouldn't be. Yeah, of course. I can see what's happened here. I wonder if you can. I'll pause and let you catch up. And let's see if we can fix what's happening. So, we've made a hashing object, but what we haven't done is actually hash the bytes from the password. So all we've done is get the ASCII bytes, the American Standard the American Standard Code for Information Interchange, the bytes for each character in our password. What we want to do is say hash. Oh, can't do it whilst it's running. Sorry. Shift F5 to stop running. Hasher dot compute hash. I want you to compute the hash from these bytes, and then even if I leave it blank, the SHA-256 of an empty string is still 64 characters long. And if I put in password, which was my horribly insecure password stored in my database, that should hopefully match what I copied and pasted into my database. So that's what we're going to search for. Great. Next thing I might want to do is say, well, this generation of a SHA-256 hash is quite useful. Let's use abstraction and decomposition so that we can reuse part of our code. So, apologies for the noise, it's just the end of a different lesson, not ours. Public string get hash, string plain text or input. And then all of this can go in here. Return the hash. Doesn't know what password is anymore because we've got a parameter called input. And then we can just say string hash is equal to get hash password. That is abstraction because we can now hide the unnecessary details to focus on the important thing, which is that we just want to get a hash. And it's decomposition because we've broken it down into smaller parts. So at this point, what we want to do is connect to the database, interrogate the database, and get the results back. So let's think what we want to try and do. Let's see, connect to the database, query the users table, determine if the username and password is correct. Right. So to connect to the database first, where I always forget how we do it. Okay, so I've just Googled how do you run an SQL query in C#. Got something on Stack Overflow, and let's try and understand what's going on and try and use it. So first of all, we need to work out what is the SQL query that we want to execute. So that comes in here really, string SQL equals something. We're searching, so it should be select. What do we want to select from? Well, let's select everything from, now what was it? I think it was the users table. Data source, server explorer, yeah, the users table. And we must have a where clause. So where the username equals and the password hash equals. So where username is equal to something and the password hash is equal to something. Now, what have they done on Stack Overflow? Well, they've got some extra stuff that we don't particularly want. Blooming scroll bar. Better. Come on. Stop selecting everything. There we go. They've got some parameterized queries here, like at, and then something like that. So we'll use that. That looks good. Where username equals username and password hash equals hash. It's a little bit like our interpolated strings that we use over here, but slightly different. And we'll look at why this is necessary a little bit later, but it's all to do with SQL injections and security. So that's the SQL, structured query language query. Next thing is a connection string. Yikes. What have we got on here? Probably not going to work. Ugh. We want a connection string. Can we get hold of that from Solution Explorer anywhere? Properties. Full path. I'm sure there's a way to try and show the connection string from somewhere. Data connections. Properties. There we go, that's what I wanted. How on earth did I do that? Okay, so on Solution Explorer, you need to double click to open your database. I needed to refresh it and then right click on the database and get properties. And then you can get your connection string. That's what I want. So string, connection, string, or just connection will be fine. Now this has backslashes in, which isn't going to work very well, so we need to escape this string by putting an @ sign in front, and then it works quite nicely with the backslashes. So what's happening here? It still doesn't like the quotation marks, so I'm going to have to put an extra quotation mark in there. And also in there. Basically saying, I want you to find the data from this location. Which is a bit silly, really. I don't want it to always look on the W drive, because how on earth will that work when I don't run it on the school network? So let's get rid of everything here, apart from the file name. Better. But we do have to be careful to make sure that this file is copied. There we go. Copy to output directory, copy always. That's already set up. That's great. Still running my program for some reason. Solution Explorer, just double checking that that file is always copied to the output folder. What does that actually do? That means that when you run your program, it creates the binary stuff here and it copies the database into the same folder as your exe so it can be opened. Okay, so we've got a connection string, but we're not actually connecting to anything yet. We'd better do that. How do we do that? Well, we want to use a SQL connection. Pop that over there. Yeah, I can. Using SQL connection. Oh, it doesn't know what a connection is. C connection. Alt enter. And which one will it be? Using system.data.sql client. Yeah, let's run with that. So we're going to make a connection. How do we make a new connection? Well, let's make a new instance of the SQL connection class. Equals new SQL connection. What does it need to be able to make that connection? It needs either nothing or a connection string. We've got a connection string. Stack Overflow called it connection string. I called it connection. I think that's the only parameter required. Yes, good. Sorry, the only argument required. Oops, extra scope brackets not needed. So what is this doing now? Well, you can see, zoom out a little bit so you can see. This is trying to connect to that database, recognizing that it might fail or the connection might close at any point, and it will free up the resources outside of this scope. Remember, this is a high-level programming language. It takes care of resource management for us. Then we can have an SQL command, structured query language command. I'll call it CMD. We'll make a new one. They've called it command string. I've called it SQL. Oops. So that means I should probably move all of that up here, otherwise I won't be able to use that SQL string. So I want to use that with this connection. Oh, and I call the connection C. Then we can fill in the gaps. So we've said there's a parameter called username and a parameter called hash. The next bit is to fill in the gaps, but I'm just going to pause there to give you a chance to catch up. So at this point, we want to match up the actual data we want to search for with the data that the user's typed in. And this is going to get round the potential security nightmare of SQL injections, which we'll talk about properly in another lesson. Where's our... Here it is. So we need to add in a parameter with a name and a value. So this thing that we've just made here, no, this command that we just made here, we can say command dot parameters dot add with value. And then we've got a name and a value. So the name is going to be the same thing that we put after the @ sign. So I want to say what the username is. And the value of that parameter is what we've got stored in our local variable. And then behind the scenes, C# is going to carefully check that there's no SQL injection in there, escape all of the characters, make it nice and secure, put in the quotation marks behind the scenes and just make it work. And I'll do the same thing. But this time I want the hash to be this local variable. Let's see what we need to do now. Then we're opening the reader, we're executing a reader, and we're checking to see what we've got. Interesting. Right, so we need a connection Let's open it, c.open. And then while reader.read. Okay, we'll try that. While, what is the reader? Ah, forgot to do that. SQL data reader. Equals command.execute reader. Okay, cmd, which is our SQL command we generated up here. But execute. Now there are different types of queries. Sometimes when you're deleting stuff, there's nothing to read as a response, but we want to read the results of this to see whether or not there is a user with this username and password hash. And then let's see. Reader.read. So it looks like we can do that repeatedly. While reader.read. Yeah, there we go. And then we should be able to access some stuff here. Reader something. So what can we do? Well, we can see the fields now. Remember our database. We should be able to access the username, the first name and the last name. So we can access the username. So let's see what we can do. Let's just display it to the debug window for now. User. Let's access it. String first name equals reader. I don't know if capitalization is important here. We can try it. But I did have capitals and definitely no spaces. Looks like we can't get something directly. Why not? What's wrong here? Cannot implicitly convert objects to string. Okay, let's do it explicitly then. .toString. There we go. Last name and last name. And we might as well get the ID as well. Int ID equals reader. Did it have a capital? Yeah, just a capital I. It's going to give me an error to say I can't do that implicitly, but let's do it explicitly. Int.parse. I know it's an integer, so it should work. Ugh. But then it has to be an object. That's horrible. Is that really the best way we can do this? Yep. Oh, you can do get something. That might be better. Get int. And then a column number. Yeah, but I don't want to specify a number, I want to specify a name. Looks like there's different ways of doing this, but this should work at least. Okay, so user ID, ID is, and then first name, last name. Will it work? I have no idea, and probably not, but we'll see. Okay, so let's try it with the wrong details. An attempt to attach an auto-named databases for the file failed. Something exists, or it's located on a UNC share. Probably is, to be fair. Ugh. Maybe we do need the actual location of it, which I deleted. It's rather irritating. Let's pop it back in and hope for the best. Grab that. that back in there. See if it runs now. Yeah, no error message now. That's good. And if I put in Mr. Dring with password, spelled properly, and log in, oh, there we go. User ID 1 is Mr. It's worked. I don't know why it hasn't got the last name in, but we can have a look at that later.